Hello everybody, my name is Ethan and I am a CFI in training. It has been a minute since I did my CFI training and I've got a few more days until my CFI check ride right now, so let's see if I still got it. Today's video we're going to be covering the Private Pilot Airman Certification Standards, or ACS, yet again, and in this video we're going to be covering Task C, weather information. So weather information, it covers a wide variety of things. It covers both the sources in which we get that weather information as well as weather theory, which weather theory is just how the weather works, what causes it, everything like that. So in today's video, this is the first of ideally a series of two. It might take three because it might take a long time to go through weather theory. But in this video, this is going to be number one, and we're going to talk through this main portion right here. So just the weather information that we're going to be getting, just the weather that we're going to be able to get online. So I have a very short little lesson written on here, and then the majority of it will just be going through the different weather sources, going through that. So the first thing that's important is to understand what are acceptable weather sources. So the FAA deems certain weather sources to be acceptable, certain to be unacceptable as far as it being the only source in which you get your weather. So an acceptable weather source is one that keeps a log that you are checking that weather. And there are a few different ones that we concern ourselves with. So one is flight service stations. So what we use in aviation is lightest flight service. You can get there either by going to 1-800-WXBrief.com or calling 1-800-WXBrief, so 1-800-992-7433, and that's where you can get weather briefings, which we'll talk about here in a second. You can also use certain weather sources such as the Aviation Weather Center, which is by the National Weather Service, which we will be getting all of our information off of here in a second. So we have AWC. The flight service station is, like we said, 1-800-WX-BRIEF. And then 4Flight is another service that we can use. And the FAA actually deems some of 4Flight's weather information as better than what they put out. So that's pretty cool. 4Flight does give really good, really brief, and pertinent weather briefings. So you can use 4Flight for that. And then there are certain third-party sources that you can use, like the weather app on your phone, or you could get on Radar 24 or anything like that. And those third-party sources are not to be used as a main source of your weather information. They're to be used supplementally wise, so that we can get that information, we can use it to help make our decisions to go or no go, but we're never going to solely make a decision based off of those. We're going to make those decisions based off of, like we said, lightest flight service, Aviation Weather Center, or 4Flight, those things. So with those acceptable weather sources, like we said, it's just got to be able to be logged. So when you call a flight service station, they keep a log of your call. It's recorded so that that flight can be monitored, and let's say that something were to happen, they're able to go back and when doing an investigation of that, say, okay, they did get a weather brief. Maybe the briefer said, hey, VFR flight not recommended, we don't recommend you fly, and you went ahead and flew anyways. That's something that they use on their end for, research purposes or whatever that may be. There's also some in-flight weather sources. We can call a flight service station in flight. We can get radar information from air traffic control, and we can also get different ATISs, which are just the automatic weather observations at airports. So then again, another preface is the importance of a thorough pre-flight briefing. So there are regulations, 14 CFR 91-103 discusses pre-flight action, what we need to do before a flight, and it talks about familiarizing yourself with all aspects of the flight. But in this video, we're focusing on the weather aspect of that. So we want to be fully aware of the weather conditions, and we want to, as one of our first steps, brief the weather. So with weather briefings, there's three different types. So we have a standard, we have an abbreviated, and then we have an Outlook briefing. A standard briefing just gives us all the pertinent information right before our flight. An abbreviated briefing, if I got a standard briefing already and maybe there were some weather changes, I could get an abbreviated briefing. And these briefings are gotten from flight service stations. So if I call Leidos Flight Service on the phone and I say, okay, I want a standard briefing, they'll give me all the weather, all the pertinent NOTAMs, everything concerning my flight. Then let's say the weather changes a little bit. I say, hey, I need an abbreviated briefing. This is my tail number. I already had a standard briefing. Then they'll tell you the changes. And then an Outlook is like 6 hours or more before your flight. You're just trying to get a good idea of what the outlook is on the day. And we utilize all three of these types of briefings when we're flying. And honestly, I really recommend using Leidos Flight Service when you go to fly, because it's a lot different than fully focusing on your own ability to read and understand the charts. You also have a person there who's trained in meteorology, trained in weather, who will give you advice. And sometimes they will say, VFR flight not recommended. I don't recommend you go out and fly right now. Or they'll say, yeah, you're good to fly. And just getting an extra set of advice, extra voice that's helping you make that decision is always helpful. Because when it comes to safety, there's no maximum on the amount of advice that we can get or help that we can get. So, going back in to our ACS, we can look and see there's a few different things now. We talked about the sources of weather. We talked about the acceptable weather products. And now these are just more specific ones. So now we can get on Aviation Weather Center. If you look up AWC or Aviation Weather Center, this is what it looks like at the very beginning. And now we can just go through point by point how we are going to go through and brief when we are going to, if I plan on flying here pretty soon, this is how I'm going to go. This is the flow of how I'm going to go through and look at my weather. So the first thing that we look through is the METAR and TAF. So METAR just stands for Meteorological Aerodrome Report. It's a weather observation that's taken once every hour. And it's typically about 53 to 55 minutes past the hour when you get it. And the data of the weather can be up to 15 minutes old. And then we also have what's called a SPECI. The SPECIs you see a little less common. That is if you got a METAR. The METAR tells you, wind's calm and sky's cleared. But let's say that a storm rolled in and it's summertime, a pop-up storm came through and it's not been a full hour yet. So instead of just waiting until the 55 minutes past the hour to release it again, they will give you a SPECI, which is just a special observation. And if there's a significant change in the weather, they will release that SPECI to let you know whatever that significant change is. So where we get on here, you go to products, you go to METAR and TAF data. So now I just go to whatever airport I want to. Let's say that I want to go to the Indianapolis International Airport. I type that in, I click load. This is now my METAR. This is the weather observation. I am currently in Indiana, so I'm going to go off of our Zulu time conversion. But it says METAR, KIND, which is the 4-letter identifier of the airport. Then we have the 22nd day at 2:54 Zulu. So I know, because I'm in Indiana and it's daylight saving time right now, that the Zulu time conversion is 5 hours. So if it's 2:54 Zulu, then I subtract 5 hours from that. That makes it 9:54 Zulu local time, which would track. Right now it's 10:44. So the last time it was released was a little less than an hour ago. So that would make it 9:54 Zulu. And the reason it says the 22nd day and not the 21st is because Zulu time is derived off of a time in Greenwich, England, which right now it is the 22nd of January in Greenwich, England. It's just not there yet in Indiana. Now, the first thing that we get is our wind. So it gives us wind direction first, and then it gives us our wind speed. So the first three numbers are the wind direction, 220. So if I think about, 360 is north, 180 is south, 270 is west, that means in between 180 and 270 is where 220 is. So the winds are coming from the southwest. And then the speed is the next thing, 7 knots. That's how fast it's going. So that's always, anytime I look at a METAR, it's going to look very similar to this. It's going to give me the airport identifier. It's going to give me the time and date. Then it's going to give me the wind. Then after that, it's going to give me the flight visibility. This is 10 statute miles of visibility. That's the max that it'll ever report. It's probably better than that right now, but that's really good visibility. We want high visibility. Then we have clouds, the sky conditions. Sometimes you'll see SKC, which stands for sky cleared, or other times you'll see a word like few, or you'll see BKN, which stands for broken, or you'll see OVC, which stands for overcast. Anytime that you see something like that, or SCT, that stands for scattered, it means the cloud layer. So then it gives us the altitude of said cloud layer. What we do to find out what this altitude is, after these numbers, I just add 2 zeros. So if I add 2 zeros to the end of this number, I'm at 7,500 feet above the ground. That's where those clouds are. Few clouds at 7,500 feet. Let's say that this 7 was instead right here. That would mean 70,000 instead of 7,000. So again, we're just adding 2 zeros at the very end. That is what we do with the clouds. And then we get our temperature and dew point spread. So we'll explain dew point a little better in weather theory the next video, but temperature first is our outside air temperature. Since it's negative right now, it's in the wintertime, minus 0.1 degrees Celsius, dew point minus 0.8. Altimeter 30.04, that's our outside air pressure, with the standard pressure being 29.92. And then here's some remarks. AO2 just means that this automated weather observation has a precipitation discriminator, which essentially just means if there's precipitation, it's able to not just say, rain. It'll say rain or sleet or hail or snow. It's able to discriminate or differentiate between the different types of precipitation. This is the sea level pressure in millibars instead of inches of mercury, which that's what the 3004 is in. And then this is a bigger breakdown of the temperature itself. So since it's 1, we have this 1 here, which means minus, and it's 1.1 degrees. But yeah, so that is our METAR. And like we said, that comes out every hour, about 53 to 55 minutes past the hour. And if it was a significant change, that would say SPECI right there instead. Give us the same update. Now we have our TAF, which we can click right there. Now we get our TAF. The TAF is a forecast, terminal aerodrome forecast. The TAF is released typically at 6, 12, 18, and 24 Zulu. So 4 times throughout the day, and it updates throughout that time. So in our TAF, we see K, I, and D, again the identifier. We see when it was gotten. So the 22nd day, 2:51 Zulu. So again, the 21st at 9:51 p.m. And this is when it's valid, from the 22nd day at 3 Zulu to the 23rd day at 6 Zulu. The most average wind is 250 at 12 knots. P6SM just means greater than 6 statute miles on the TAF. It doesn't go ever higher than greater than 6 statute miles. The clouds are broken at, and remember we add 2 zeros to the end here, 10,000 feet. And this is talking about wind shear, which tells us 020, or it's taken at 2, and it's 250 at 50 knots. Dang, that's pretty quick. Okay. Then we have different time increments in which this is valid for. So from the 22nd day at 600 Zulu. So again, we think of the Zulu time conversion, that would be 1 a.m. this time. The 22nd at 800, which is 3 a.m. And then 1900, which is 2 p.m. So then it just gives us the forecasted winds, 280, 22 knots, gusts up to 34 knots, greater than 6 statute miles, scattered at 10,000. Then at 3 a.m. or 8 o'clock Zulu time, we have 290 at 14 knots, greater than 6 statute miles, few clouds at 25,000 feet. And then on the 22nd at 2 p.m. or 1900 Zulu, we have 270 at 12, gusts up to 20 knots, greater than 6 statute miles, scattered at 13,000 feet, and broken at 25,000. Excuse me. So that is our METAR and TAF. We also have this little decoded thing, which is pretty nice. This just puts it into human English terms for us, you know. It can be kind of hard to read sometimes when you're very first starting out. So what I encourage you to do is look at it, kind of test yourself a little bit. I think that's what that means, and then go to decode it for yourself. That is a very useful thing. And then at the very beginning, we also see pilot observations, pilot reports. PIREPs is what they're called. And with that, we get it from right here. Again, we go to products, PIREP data. So now I go to my airport center. Let's say that it's Indy again. I can choose what radius I want it from. Maybe I say 20 miles out. Okay, there's none 20 miles out. None 50 miles out. Dang, none 100 miles out. Okay, 150 mile radius. So these PIREPs are a little bit hard to understand, and I am not going to just sit here and talk through each one because there's a lot of different things that can be in a PIREP. So what I recommend, and I'll put this link in the description, but Skybrary Aviation has a very useful thing on PIREPs. So it says why PIREPs are given. If ceilings are at or below 5,000 feet, visibility at or below 5 miles, air traffic control will ask pilots to give them. And then this is just what all the things are in a PIREP. So the 3-letter station identifier. So if I look, that's LEX. Then report type. UA means normal. UUA means urgent. So routine or urgent. Then location. That's over. That's LEX. So Lexington. Then we have time, altitude, aircraft type, sky cover, all that stuff. And then they give examples actually right here on how to decode it, understand what it's saying. So I would recommend you look at this in the description. Very helpful. Test yourself again. You can go through, look through, try and figure it out, and then go back and look and be like, okay, I got this wrong. But with PIREPs, it's just important to remember what time it was taken, because sometimes they can be pretty far, again, past, because it's time in Zulu time. So you're just wanting to see when it was, because that can be an important thing. Some of them can be like, 30 minutes old, and that might not be as pertinent to you. It's just important to, with any weather information, recognize when it was released, because that is very important. But those PIREPs are a pilot report. It's a real-time observation. Pilots will give you, exact cloud heights, exact cloud tops or bases, or if they picked up icing or turbulence, whatever it is. And that is one way that you can see that. Pilot reports are especially useful in the wintertime when it comes to figuring out if, like, where the freezing levels are at, if there's going to be icing or turbulence, that kind of stuff. So next we have the surface analysis chart and ceiling and visibility chart. So if I get on Aviation Weather Center yet again and I go to Prague charts. Prague charts are our surface analysis charts. So everybody has heard of cold fronts. Everybody has heard of warm fronts. You've probably watched the news before, so you know what those are. This Prague chart, essentially, once we'll dig into what cold and warm fronts as well as high and low pressure systems do in the weather theory video, but we can just look on this Prague chart and see its valid time right here. So 3 o'clock UTC, the 22nd of January 2026. So again, we do that Zulu time conversion to find out that this would be 10 p.m. is when this was gotten. And then we see these blue lines with the triangle. That is a cold front. So we've got a cold front here, cold front there. This red line with the semicircles, that is a warm front. If you see it go alternating, blue, red, blue, red, blue, red, that's what's called a stationary front, which we'll talk about that, but it's just two fronts button up against each other. The big L stands for low pressure system. The big H stands for high pressure system. And then we have these lines on here that are called isobars, which are lines of equal pressure. These isobars are in millibars, which is not what we use in America for pressure. We use inches of mercury, but 1016, that is what that is. And then we can also see some precipitation in here. And there are legends. If you click on legend, it tells you, so that is snow up there, or this is rain, or, you know, whatever it is. So like we said, high and low pressure. These orange lines are called troughs, lines of low pressure. And then there's also ridges, which are lines of high pressure. But again, we'll talk more about this in weather theory. But you can go through and click through and just see how it's all going to move. And see how it's going to pertain all the way up to, dang, there's going to be a big old winter storm. But you're able to go pretty far out with this, which is super nice. So that's our surface analysis chart, or PHAK chart. And then ceiling and visibility chart is, we just go in and it gives us, if we go to weather, and this is part of our GFA tool, graphical forecast for aviation. So this will probably be the last thing that we have. So if I click on GFA forecast, anything in here, and I click on here, this is the active layers. So these are all these different things that I can put in. I can put in graphical airmets, warnings, center weather advisories, SIGMETs, weather symbols, you know, all that kind of stuff. But I can also click that I want the ceilings. So this shows us our ceiling in here, and we can look at our legend, tells us what the different colors mean, and gives us an idea of where it's at. So like right in here, that's that shade of blue, so it looks like it's about 1,000 feet in AGL. And this also shows us different things in here, which we will talk about in a bit. But that's our ceiling chart. Our visibility chart, same thing. It just shows us what the visibility is. You click on legend, tells you in statute miles what it is. So right now we're good right here. But if I look right there, it looks like it's about 4 statute miles if I look based on the color. And that's just all really useful because, again, as private pilots, we're going to want to fly in visual meteorological conditions. So we can get an idea of where the ceilings are, how good our visibility is, and that will help us to choose and make this go no go decision. Because again, that's the money maker right there. That's the big term. Are we able to go, or are we not going to go based on this weather that we're looking and briefing ourselves on? We have wind aloft, or winds and temperature aloft forecast, which winds and temperature aloft forecast, we go to products yet again. We go to wind and temp data, and on here we pick which one. So north central is where Indiana's at. I click load data, and then it tells us when this forecast is given to us, when it's valid for, and remember these are all in Zulu time. That little Z, that's what that means, which is the time in Greenwich, England. Tells us when we should use it. Tells us that the temperatures are negative above 24,000. So this has some little nuances to it. I would recommend to look up how to read a wind and temp aloft forecast. There's good stuff put out there online by Skybrary or by Pilot Institute. But you see the identifier. You see what altitude, so 3,000, 6,000, 9,000, all the way up to 39,000 when we're on the low. And then what we get is, if we see something like that, the first two are our wind direction. So 30, again, they're condensing it. They're not using a whole lot of numbers because that would make this even more confusing than it already is. So that is, we just add a 0 to the end. So 300 is the direction. So again, that's northwest if we think about a compass at 41 knots. And then the temperature is minus 13. If it was a positive, there would be a plus right there. Like right here, we see plus 00. And then, yeah, once we get above 24,000, it takes away that minus symbol that's typically there. And that just means that this is minus 53 on the temperature. So, again, I would recommend go look those up. I'll even put one in the description on how to read the winds and temps aloft forecast because there's some nuances to it with certain wind speeds. And, you know, it's just important to know those, but most of the time there's not going to be too awful much different when we're flying at low altitudes just because the wind speed doesn't get all that fast. It gets a lot faster when we go super high. But that's our winds and temps aloft forecast. That's where we'll find that at on the Aviation Weather Center. And then the convective outlook chart, you just have to look up convective outlook. And when you look up convective outlook chart, you can get on like the Storm Prediction Center, things like that. They just give you an outlook of convective activity, you know, when they suspect storms will brew. And right now it's winter time, so there's not going to be too awful much on convection. So severe weather outlook, you see, there's not really much going on right now because it's so cold outside. But you can see just like little green circles, and if I look at that, that's just giving me a legend of, you know, there's a marginal chance of convection. And then it tells us when it's issued, when it's valid for, and again, that's important for us to know when something is issued, when it's valid for, because that is what helps us know whether or not we should actually use it. So using the convective outlook is something that you want to use, but I would recommend more using radar and using our TAFs, the Terminal Aerodrome Forecast, as well as once we get into weather theory, you'll understand a little more how the weather works, and then that will really help you out. Okay, so last thing we have is in-flight aviation weather advisories, including airmets, sigmets, and convective sigmets. So these in-flight weather advisories, we have, like we said, airmet, sigmet, and convective sigmet. Airmet stands for Airman Meteorological Forecast. It's most pertinent to the small guys, to GA aircraft, general aviation aircraft, but it can be considered by everybody. These are issued for 6 hours, and they have 3 different types. So the 3 different types cover turbulence, IFR conditions, and icing. So turbulence is Tango. The IFR conditions are Sierra, so these are just phonetic alphabet letters. T, S, and then Zulu is icing. So the way that I think about it, Tango for turbulence, duh. Sierra talks about IFR conditions, so clouds, so seeing, Sierra, and then Zulu is icing. We can get on and look for GE airmets, the graphical airmets, and these are all these different things. So I can see turb low right there, and it tells me there's moderate turbulence at the base of 10,000 feet, top of 18,000 feet. Or I see IFR, so that would be a Sierra airmet. So this says the ceilings are below 1,000 feet, visibility below 3 statute miles, precipitation of mist and fog. So these are just giving us that information. And again, it's most pertinent to us little guys, the GA aircraft. The sigmets are the next thing, which sigmets are significant meteorological forecasts. These not only apply to the little guys, but also the big aircraft. These are valid for 4 hours, and they're issued for a certain bit of things. We have severe icing, severe or extreme turbulence or clear air turbulence. We have volcanic ash, and then widespread dust storms or sandstorms that lower the visibility to 3 statute miles. These are unscheduled, so right now you'll mostly see convective sigmets like this right here over New York. But here's what a regular sigmet would look like. This just says turb right there. So turbulence severe, and then this goes through and lets us know of all of that. It begins at this time, the 22nd, from 125 Zulu to 525 Zulu, top at 3,000 feet, movement stationary, change, it's weakening. So it says standard domestic region, severe turbulence forecast within 50 nautical miles, wide line between, that is the lat long. So Again, there's better ways, like if you have ForeFlight, it'll put that into more English for you. But that's just something that you can see and you know, okay, I see that that's a SIGMET. When I get on product, I go to SIGMET. So I know that it's valid for 2 hours and it can be these certain things. And then it tells you what it is. And then a convective SIGMET, like we have right here. We got pretty lucky to have one in the wintertime. But it's valid for 2 hours and it's issued 55 minutes past the hour. So these are issued for more severe things that are associated with convective activity or thunderstorms. So surface winds greater than or equal to 50 knots, hail at the surface greater than or equal to 3/4 of an inch in diameter. If you have tornadoes, embedded thunderstorms, which are like thunderstorms within an already cloud layer, so they're more obscured, harder to see. And then squall lines are another one. So just a big line of thunderstorms that's ranging a very wide area. So this convective SIGMET tells us the top, 17,000 feet, movement 250 at 20 knots, so not that fast. This says valid until this time, 5:55 Zulu. And this just gives area of thunderstorms moving from 250 at 20 knots, tops to flight level 170, so 17,000 feet. So it's a pretty weak thunderstorm, only going up to 17,000 feet. But that's how we get that information right there. If we're ever wanting to look at convective SIGMETs or SIGMETs, we just click on products, go to SIGMET. So that was a lot of information right there. And essentially, you'll get more used to this flow of going through things as you fly, more as you get used to doing this whole risk management process, briefing yourself on all the pertinent things before your flight every single time. So I really recommend using Aviation Weather Center at the beginning. ForeFlight makes it easy, so get used to reading it on your own, using it with Aviation Weather Center at the beginning, and then you can transition into ForeFlight once you have a better idea of these weather products. But that is all. Again, we're really focusing on this go, no go decision of, is this weather good enough for me to fly? And the saying is, I would always rather be on the ground wishing I was in the air than in the air wishing I was on the ground, because things can get from bad to worse pretty dang quick in aviation. And if you play around with weather, you can especially get yourself into some pretty bad situations. So again, just focusing on briefing ourselves with the weather all the time. Like I said, I'll link a few things in the description that'll help you with reading these charts, with understanding certain things like PIREPs or certain things like winds and temps aloft. And then also, if you want more information on these things, the Pilot's Handbook of Aeronautical Knowledge, Chapter 13, you can look this up. It's free online on the FAA website. PHAK Chapter 13 goes over aviation weather services. So this gives you all these things that you can get. It even talks about different services that you can get from air traffic control, which just understanding with those that they're not always real time, like they can be old data, so you never want to fully focus on what their radar tells you. You want to give yourself a good margin of error, good margin of safety. But going through reading PHAK Chapter 13 is also going to be really helpful. So that is all that I have as far as weather information goes, as far as, weather services that we're going to use. And the next video that we'll have will cover weather theory. So thank you so much for watching, and I'll see you in the next one.